if you imagine in your mind's eye a fifth degree polynomial, okay, a fifth degree polynomial, here's the reality. It's going to have 5 real or complex zeros. It's going to have 5 of them. Now, maybe they're all real. Maybe they're all complex. Who knows? But it's going to have 5 zeros. Okay? It's going to have 5 zeros. So, just keep that in mind, right? Then we have the complete factorization theorem, which states that what we're going to have is no need for caveats attached to some of our zeros. We can take a 0 and write it as a factor. Now, here's something to think about. Technically, I'm not guaranteed 5 unique zeros for a fifth degree polynomial, because what if I have like a triple root at 2? Well, then you would say, oh, well, you've got 2 zeros, which is true. But you've got 5 factors. You just listed x minus 2 3 times, okay? So here's the real goal. The real goal is to take a polynomial and turn it into this. That's the goal. That's what we've been doing this whole chapter without necessarily doing it that way, or you know, maybe not getting right to it, but we've built the theory. Now it's here. And we can do it for everything, even if it's got complex zeros. That's a big deal. And I'm going to walk through a few of those examples. So, I want you to find the real and complex zeros of this thing. Now, here's what we're going to do. I want you to pause and try this exercise. Here's what I need you to do. You're going to need to break down this polynomial until you get down to a quadratic polynomial and then solve the quadratic that's left. So use the rational zero test, start guessing, find that first factor, and then you're going to have a quadratic thing left. Then what I need you to do is go ahead and solve that quadratic, and then we'll talk about what comes out in the end. Okay? I'll give you a second to do that. So I want you to try it on your own first. Hit pause, go ahead and try that. All right, here we go. So first we're going to use the rational zero test theorem. And we get r is equal to plus or minus 10, plus or minus 1, plus or minus 5, plus or minus 2, over plus or minus 1. So now what we end up with is this collection of possible zeros, plus or minus 10, plus or minus 1, plus or minus 5, or plus or minus 2. I start iterating through these things. I check plus 10 first, then I check minus 10, then I check plus 1, then minus 1, blah, blah, blah. Well, guess what? 2 hits. So I take 2, I put it in the box, I do my synthetic division. Okay. So I do my synthetic division. Where these coefficients came from is up here. Boom, there's the 1. There's the negative 4. There's the 9. There's the negative 10. Okay. And I found that 2 was a winner. That's huge. Now, after I do that, I'm left with these coefficients of the quotient. Okay. And now what I'm going to go ahead and do is solve this quadratic, because that's what I'm trying to do here. Now, because I know that x equals 2 works, I know that I have one of the zeros being at x equals 2. So now I'm going to use the quadratic formula to find the others. A is 1, B is negative 2, C is 5. Pause here and go ahead and do quadratic formula for me and simplify it all the way, if you didn't do it before. All right, now I'm going to use quadratic formula, and I plug all these things in. And what I end up with is 2 plus or minus the square root of negative 16 over 2. That's super problematic. That's not cool. So here's what I'm going to do. This negative under a square root, what we can do is just basically call this guy, or let's rethink this in general. What I'm going to do is I'm going to think of this as the square root of negative 16. I'm going to rethink this as the square root of -1 times the square root of 16. Well, square root of -1. We know what that is. We actually defined that to be I. And so then I still have my square root of 16, which we already know is 4, but we'll get to that. Okay. So now I take that I out front, and now I don't need to worry about the negative. And so then I end up with 2 plus or minus 4i over 2. Use greatest common factor, factor out the 2, you'll see it cancel, and you get 1 plus 2i and 1 minus 2i. So here's what I know. I know that I've got a 0 at x equals 2, 1 plus 2i, and 1 minus 2i. All right. Now, what you're going to do here is find all the zeros of the polynomial, and you're going to completely factor it over the real numbers, and then you're going to state all those factors. Okay? That's really what we're asking here. So let's just go ahead and find all the zeros. Just take a second and find all the zeros for me. Don't worry about writing them out as factors, just find the zeros, and we'll do the very last step at the very end. Okay? Find all those zeros for me. That means you're going to need to use rational zero test. You're going to need to check and see if one takes when you're plugging things in and guessing them. And then you're going to need to use quadratic formula. You're going to need to simplify, blah, 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 blah. All right, so go ahead and get cracking on that. Oh, and hit pause and just wait a second. All right, so first I'm going to write this polynomial in standard form so that I don't make a goof. This 0 is now vitally important, okay? Now, I'm going to use my rational zero test, and I find that I'm going to be checking plus or minus 1/9, plus or minus 1/3, and plus or minus 1. Now, I've got the minus 1/3. I'm going to go ahead and try that one. And look at that, it takes. That's pretty cool. So I drug the 9, blah, blah, blah. I'm assuming we know how to do this at this point. So now I know one of my factors is x minus 1/3. And then I'm left with these guys here. So I'm left with the 9, the -3, and the 3. So now I'm going to use quadratic formula. And we get to 3 plus or minus the square root of -199 over 18. Ooh. Let's simplify that square root of 99. So I get 3 plus or minus I square root of 99 over 18. Now we'll reduce that radical. I'll leave that to you all, but that's going to be a 3 square root of 11. And so then I get 3 plus or minus 3i square root of 11 over 18. I'm going to factor out the 3 and reduce. Okay, so you see here I've got the 3 factored out, which now means that I'm going to get rid of the 3 and I'm going to change this 18 to a 6. All right, and now I get 1 plus or minus I square root of 11 over 6. This is one of those roots. And this is the other one. So, okay. We've got roots. We've got zeros at -1/3. We've got one at this thing, and then one at this guy. So now what are my factors going to look like? Well, I take the zeros and I just mash them into an x minus. X minus, copy, paste, boom. X minus, copy, paste, boom. And so now what I end up with is this as my total linear factorization. Technically, this is what we were doing before. Now we're just allowing for weird things to go in there. Okay. And that's 3.5. That's really it. All you're doing is taking, you need to know how to do computations of complex numbers, addition, subtraction, multiplication, and division. And then when you're basically doing 3.5 problems, you need to be prepared now to do stuff with the I as a complex solution. So like when you see I's in here, that's now 3.6. All right. Be working on these problems. I think you'll find the video from this lecture to be helpful. I would go through and review your notes from 3.5 that we did before break as a frame of reference. Good luck out there.